Hey everyone, and welcome. Today, we're going to pull back the curtain on one of the most powerful, but maybe least understood security features in all of ASP.NET Core, the Data Protection API. So if you're a developer, I bet you felt this, that little knot in your stomach when you have to handle something sensitive. You know, cryptography is hard, and if you get it wrong, well, the consequences can be pretty serious. It's a totally valid fear. And that brings us to why trying to do this yourself is, frankly, a minefield. Rolling your own crypto isn't just about picking some cool-sounding algorithm, it's about avoiding a dozen different ways things can go catastrophically wrong. I mean, you've got to worry about managing your keys, you have to rotate them regularly, you need to store them securely, and on top of all of that, you have to make sure no one can just mess with your encrypted data. One little mistake in any of these areas and your entire security model just falls apart. But here's the great news. You don't have to do any of that. ASP.NET Core already has a built-in guardian that's designed to handle all of this complexity for you right out of the box. At its core, the Data Protection API is basically like a super secure locker. You just hand it your data and it takes care of everything else for you. We're talking encryption, key management, making sure it's tamper-proof, the whole shebang. It just works. And it is absolutely secure by default. Under the hood, it's using a really strong standard called authenticated encryption. That means it uses AES to keep your data secret, that's the confidentiality part, and it combines that with HMAC SHA-256 to guarantee integrity, which is just a fancy way of saying it knows if the data's been tampered with. Okay, so the framework uses this stuff internally, which is great, but how can you use it to protect your own application's data? Well, it all boils down to two key ideas, a service called IDataProtector, and this concept of purpose strings. So the IDataProtector is the main thing you'll interact with. It's the service you use to actually protect and unprotect your data. A good way to think about it is like a personal, secure safe deposit box built for one and only one type of secret. And that brings us to the purpose string. This is how you label your safe deposit box. But, and this is so important, it's not just a label. It's actually baked into the encryption process itself. This is what guarantees that data you protect for one purpose can't be read by a protector that was made for a different purpose. And this right here shows that isolation perfectly. A protector created with the purpose string auth cookie can encrypt and decrypt auth cookies all day long. But if you try to give it data that was protected for a reset token, no way. The decryption will fail. They live in completely separate cryptographic worlds. So for you, the developer, the process is just dead simple. You hand over your data, you give it a unique purpose string, and you get back a totally secure payload. All that heavy lifting and cryptographic complexity is just handled for you. Now, you might be thinking, what about the keys? That's one of the biggest headaches in crypto, right? Well, the Data Protection API has an amazing solution for that, called the keyring. The keyring is exactly what it sounds like. It's the collection of every single encryption key your application has. The best part is that the framework manages this whole thing for you. It generates new keys, it retires the old ones, and it makes sure they're stored safely. By default, every key only stays active for 90 days. This automatic key rotation is a massive security feature. It dramatically limits the window of opportunity an attacker would have if a key ever, somehow, got compromised. And this timeline shows just how smooth that whole process is. A new key, key B, gets created before the old one expires. Then, once key A hits its 90-day limit, it stops being used for any new encryption. But, and this is the magic part, it's kept around so it can still decrypt any old data that was protected with it. So you never lose access to your old data. It's seamless. Okay, so this all works like a dream on a single server. But what about the real world, where we have modern, distributed apps? Let's talk about making this work in a web farm or a cloud environment with multiple servers. This is the classic scaling problem, isn't it? If each server has its own little secret set of keys, how on earth are they supposed to understand each other? Here's the classic failure scenario. Server A encrypts a login cookie for a user. Then the user's very next click gets sent by the load balancer over to server B. Well, server B has a totally different keyring. It looks at the cookie, has no idea how to decrypt it, and boom, the user gets logged out. Not a great experience. Thankfully, the fix for this is really straightforward. It's just two simple configuration steps. First, you need to store that keyring in a central place all your servers can get to. And second, You have to tell all your app instances, hey, you're all part of the same application. And you've got plenty of great options for where to put that shared keyring. You could use a simple network file share, go cloud native with something like Azure Blob Storage, put in a central database, or even use a Redis cache for super low latency access. All right, now for what I think is the coolest part. We've been talking about how you can use this API, but the truth is, it's been silently protecting your applications this whole time, whether you knew it or not. This whole system we've been discussing, it's the cryptographic engine behind so many of ASP.NET Core's most important security features. You know, authentication cookies, they're protected by this. Those anti-forgery tokens that stop CSRF attacks, yep, this API. Password reset tokens, temp data, they all depend on it. And that's really the bottom line. The data protection API isn't just some optional tool you can use. It is the fundamental, unified cryptographic backbone that keeps the entire framework safe and secure by default. It's an incredibly powerful and easy-to-use tool that solves a really, really hard problem for us. So the question I'll leave you with is this. Now that you know how this built-in Guardian works, what sensitive data in your own applications are you going to protect with it?